Right, so for those, oh no, cancel. It's recording already. Right, so for those who are behind or haven't submitted work, or you're obviously going to need a strategy to get the most out of moderation, and I'm going to suggest that you I'll tell you what I think you should do in the list, what you should focus on, to try and present the best picture of what you're capable of. Okay. Okay, right. So I'm going to start again. I just want to make sure. Can you guys see? Can you see the screen? There's a part here in Solidworks. Can you see that?
No.
Not yet.
No, we can't.
Okay, let's just quickly go to share screen. One. I think you only need the one. And now, can you see it now? Seth, you're here as well. You can see it. Great. Okay.
Yeah, we can.
Seth is here.
Yeah.
Hams is here. Jacques is here. Jake is here. Hi, Jake. Cool. Okay. Right. So quickly hop over to what I figured out in the break. Hide that. Okay. Remember I said in the last time that I couldn't get this little thing here to work, where I went to edge flange and it had to do with this relief type. That's just user error. It's just me being silly. The reason for that is quite simple. It only applies to let me show you. So I'm going to go back to this edge flange, and let's take one of these away. So I'm going to click on edge 3, delete. Okay, so in fact I'll show you a few more functions in SolidWorks that will be useful. So if I don't like the length of this, for instance, if I want that to be smaller than this, I can just go into the sketch, edit sketch, and I can drag any one of these points in by however much, and I can dimension. So I can dimensions from the edge. So 5, both sides. And I can also, what I like to do is I like to dimension the height, because then I can control this inside my drawing without going into the feature. I can just double click on the actual feature and double click on the dimension and change it. So you can do all those sorts of things. You can also now add other bits and pieces. So let's see if we can't, let's put a circle here, for instance. Anything you want. If I exit now, you'll see it's put that feature in, and here we can see the bend relief. So that's called the bend relief because if you picture when people bend these items, the bend starts from this point, it goes around that corner up to that point, and this little point here, this little section here, there's an enormous amount of stress. So if that weren't in place, then it starts bending this piece as well. So let's just quickly go over to this, and that's called a tear. So that's a tear relief. So that's the tear like that. Right, so you can see now I'm going to have to cut into, if you can picture in sheet metal, you'd have to cut a slot in there without any relief. There's no, like, how do you get that piece to bend from this piece without having cut a slot in it? So typically a tear relief you would use in this configuration. You would go to that one there. Now you can do that bend without there being too much stress on that point. Okay, so that's how you do that. That's where the bend reliefs apply. Let's quickly show you the OB round one. So OB round, and here you can determine the ratio. So if you want to make it much smaller, let's say 0.25, you can do that. I'm going to go back to that one there. Sorry about that. And there you see it puts in a little round in there, so that's why it's called OB round, I'm assuming. And that's quite common. Okay, so the other thing I can do is, once I've got one part that looks like this and I want this other part to look the same, I can go to the sketch of that other part. By the way, those are the two sketches. There's that one. You can see it highlighted. It shows you what the sketch belongs to, which part of the edge flange it does belong to. So if you've got them opposite one another, you can go into this sketch. Just see. Yeah, no, it's not doing it. Right, here, what I was going to say is you can delete this and just copy. It's not going to do it. There it is. Okay, so I deleted it. So what I can do is I can delete the existing sketch, and now that I can see the edges of my other sketch, I can couple these. So I can select those three lines and go to the convert entities and then just trim these edges. And now whatever I do to one side will happen to the other side without me having to go into that sketch. So let's go to this feature. It's at 10 at the moment, and let's say I want it to be 15. It's updated it, and you'll see that's updated this side as well. Or if I double click on here, and this side I want just to be 2, it'll update both sides. Right, so those are some useful tips for you to use to shortcut your workflow. Okay, so I'm going to exit this because I don't need it anymore. Quickly go across to this baby here. Okay, so I was explaining before the Zoom meeting ended what it is that I want you to do in this next project. I'm going to give you this PCB with all these parts as a step file. This little part here is an aerial coupler, which I don't have the connector for, but it's good enough. It's just going to be the basis for creating these holes. So you'll see at the back here I've got the holes in place, and I'll show you how to do that as well. I've got a back tab which is bent down. I've got these side tabs which I'm going to show you how to create, and then this bottom piece has these jogs in, which is the next thing I'm going to show. So I'm going to want you to couple these standoffs to this base plate, and then that PCB to these standoffs, and then that piece will have, it doesn't have it yet, but I'll put them in. It'll have a tab with a hole in it that you can punch a hole in here that you can screw into here, and it'll have tabs on the side so that it connects into. So what happens is those get pressed into these holes, interference fit, tolerances coming into play, then that gets screwed onto those standoffs, and then this piece gets screwed onto the base, and that forms a unit. Those three form a unit, which you then slide in because of this jog. You slide in here and they meet those holes in the back, and then one more screw or two more screws will put a screw in there and in there, and there the holes are for the screw inserts, which I'll give you. They'll look like this, but they'll be slightly smaller. So that'll be the project, just so that you have an awareness. But the only things you have to design are that and that, those two parts, and then give me drawings for those two parts, and then obviously an assembly drawing as well. But the rest I'll give to you. All right, so let's deal with this object here, which I've started, just so that we don't waste too much time. So I've got the basic square, which I know these are the dimensions that I want, which I've fully dimensioned, and I'm going to click on that and go to base flange. And because it's quite a small part, it only needs a wall thickness of about 0.9. So 0.9, let's let's leave it like that. Alright, so now I want to put some jogs in. So I'm going to click on the surface, put a sketch in, and put a center line straight away, and then offset that. Actually, I'm going to offset from this edge just one. I think 10 is right, which we'll find out shortly. Okay, so there, the dimension is in. So if you're doing a jog, you can't do more than one sketch at a time. You have to just do one sketch. You can't, like, I couldn't put the other side in right now. I'd have to leave it like this. So once you've got a line, which is going to be used as the jog, and it always has to be a straight line as far as I know, then you can go to the jog feature, which is at the top here. So it's in the second frame. It's top right hand side, jog, and it's going to ask you for, you see I've already selected the sketch, so it's actually selected the sketch for me, but it's going to ask me for the fixed face. So what that's asking for is, given that that's the line, do I want this side of the line or that side of the line to be fixed? So obviously I want that side of the line to be fixed, and you'll see it visualizes for you straight away what the jog looks like. And here you can decide on how high the jog needs to be. So I know my material thickness is 0.9 and I need a bit of a clearance, so I'm going to leave it at 1.1, that's good. And then here you can decide on how that offset is decided. So you can see it grows larger, or it just goes straight, or as I've got it here. And then I can't remember exactly what these do. Yes, that they move where the jog positions itself. You can see as I'm selecting those. And then the jog angle, that's obviously that's the angle here, that angle there, which we'll leave at 45. I think, as far as I know, that's a kind of a standard. Let's leave it like that. So voila, we have a jog. Let's put another line in. Sketch. Don't want the whole thing, just want that line. Okay, so straight away it's gone to jog. It says which face do you want fixed? I want that one fixed. And there we go, we've got a jog. So I'm going to quickly put in some holes now on this face. And here's a feature we haven't used at all yet, which is called the hole wizard, which is it's a very neat tool. So I'm going to click on this hole wizard. And in here we have all kinds of holes. So counter bore, countersunk, a straight hole. You can have straight tap. You can have a drilled hole, where it's not a drilled, a threaded hole. I think it's in here. Yeah, that's it there, straight tap. So that's a threaded hole. So these are very useful if you're using lots of fixings. All we need for now is a straight hole, because we're going to fit something into it. And then you can use standards, and you can show screw clearances or drill sizes. So you can pick like a standard drill size for whatever you want. But if I don't want any of those, I can just click on this button, which is show custom sizing, and I can put in my own size. I know this needs to be 5.9 millimeters because I did this beforehand. So once you've got that, you can move over to positions, and you can just place the pieces that you want, however many holes you want. So I'm going to put 4 holes in. I'm going to line them up as best I can. Okay, and then put in the center line. And then just do a little bit of defining. So that's right, and then these two must be vertical. As those must be vertical, and then those should be horizontal. And I just need a few dimensions, so from here to here. Can't remember what this should be, but it doesn't, not, we can change it afterwards. And I can go from center to here. Oops, that's opposite way. 40. Sorry about that. Come on. Leave it. That should be 65. Sorry, I need to change this one because it's not going to work otherwise. 30, I think that's right. Okay, so I've got all my holes fully defined. That won't show fully defined actual hole sizes. It'll just show the points as fully defined. So once all the points are black, you know you're okay. Alright, so I exit this and those are my holes in place. And so anytime I want, I can just double click on this and decide to change a dimension if I want. And you can also do configurations. Won't show me, just going back to the configuration thing, if I double click on this, it won't show me, sorry about that, let's try this again. Right, if I double click on this, it won't show me a configuration either in this, on the left hand side or in the actual bar. Can I get that to, no, it won't do it. It won't show it to me until I go and add a configuration, because there's only one configuration. So the moment I add a configuration, then I can change this. So that's my base done. I'm not going to add more holes in here because you've seen how to do that. I'm going to go across to this one here. So there you see I've created that piece. And now I'm going to collapse this. And let's just hide these two. Or suppress them for now. Okay, so there's another way of creating a sheet metal part which I haven't showed you. If I go to front plane, for instance, and put a sketch on here, I'm going to draw a sketch of the shape that I want to go around here. I'm going to use that to extrude the sheet metal part that I've got. Has someone got a question? Yeah, Seth, I am recording. Okay, sorry, that was just a message from Seth to see if I was recording. So I'm going to click on my usual center line and then go to this one here. Give this some dimensions. When you do this shape that I'm showing you now, which we're going to use as the basis for the sheet metal, don't put any corners in because the corners are going to be put in for you by the sheet metal command. So I'm going to select all of this and just say Control C. Don't worry about the warning message, because currently that sketch, if you have a look, that sketch sits inside my assembly. It doesn't sit inside the part. So here's my shroud as a part. I'm just going to quickly unsuppress it, and I used a sketch. You can see a very similar sketch to that to create that part. So I'm going to start that from scratch though. So let's give ourselves an offset of 5 millimeters. Oh, right, okay, so the problem here is, if you have a look here, you can see that because I've got the custom relief type as a tear, and this is the reason why I actually pulled it in, that's going to be a problem. I think this is the problem. Let me just make sure. If we go to an OB round and give it something like that, there we go. Alright, so this should be better. There we go, it's done it. Alright, so I need that OB round, and I've got a bit of a problem with this, but I'll figure out how to get that. It still needs a bit of... In fact, I should be able to double click on this and get all the features I need. Let's make that 1 millimeter, so that's the offset. Still doing it, so there is still something wrong, but you get the picture. It's definitely, I think it's here between these two. Right, so I'd actually probably go and change the shape of that thing so it doesn't do what it's doing here. We'll go to File, New. Front plane and Control V, and so it brings my sketch in. I just need to move it from that point to here. I think we have to now. Here you have to be a little bit careful. If it doesn't want to connect straight away, just click on the end of it, click on the origin, and say make coincident, and then everything. If you've got a fully defined sketch, it'll all go black for you in any case. So all I need to do now is to mirror this. So go to the mirror command, select all those items, mirror about this one here. Okay, and that's all ready. I can, of course, extend these dimensions if I want to. I'm not going to worry. So exit the sketch, and from here I can select the sketch, and I can say under sheet metal, base tab, so it's not lofted, it's base tab, and now it's going to assume that you're going to use just an open sketch which has got no thickness to it as the basis for a thin wall. So you'll see it actually selects for you, if I can find it. It actually just adds it in. Sorry, it doesn't give you a thin wall feature, it just says that you have a thickness. It's selected one that I've already put in here, so the sheet metal parameters are, it's a thickness of 0.9. I can change this if I want, and it's given me a default radius which should be 0.9, not 1.1, K factor of 0.4, and I'm going to leave the auto relief at tear. Remember, we can make it one of those three. I'll leave it at tear, and here all I need to do now is type in how deep I want it, and I've got sheet metal part. So let's just check that it's sheet metaling by doing the flatten. There we go. So those are all my bends, 1, 2, 3, 4, 5, 6 bends, and it's flattened it. If I unflatten it, I've got the part. So what I want to do now is I want to add a tab in the back to be the basis for the back plate. So I select this edge and go to edge flange and just drag down. So I'm going to do it quite simply like that, just to show you. Once you've got it in place, you'll see, right, so here I've got it to fail. You can see that's giving me a nice big yellow warning. This part intersects itself after bend operation. So if I go to flatten, see, it flattens nicely, no problem. But if I unflatten it and I zoom in here, that little bit there is interfering with this little bit here. They're too close to one another. So there are two things I can do there. One is I can go into this feature and I can say, well, give me an offset to fix that. I could have gone and measured that. Just give it a 0.2, and you see the error goes away because I've just made that face 0.2 millimeters away from this face, or 0.2 millimeters further away. So that's one way of doing it. The other way is to select a different kind of connection So if you go back to this, so you could select this one instead. You'll see it's bumped it up. Take the offset away. But that does mean that you're going to get quite a large gap in there. So it all depends on what you're aiming for, on how you hope the thing should look, all those sorts of things. So I'm going to go back to this one here. And the first thing I'm going to do is I'm going to edit the sketch, because I want these to come in a little bit, because I want that little bend relief. Okay, and then so I'm just editing the sketch here. It doesn't seem to want to do it. Let's go like that. So I've got a symmetrical sketch, which means I can now drive the width of this thing using a single dimension, which I want to make 165. Let's see if that's going to do the job. Yeah, it's done the job. It's just that now I haven't coupled that center line to drag it across. There we go. Alright, there it goes black. So 165 is a little bit too large. So 163. Yeah, perfect. Okay, so while I'm in here, I can now change the shape of this. I want this thing to follow this shape here. So instead of redrawing everything, I can just click on those edges and select this convert entities, right? And then I'm going to delete that top line. Oh, deleted the whole lot. Delete the top line, and then I'm going to connect these two here. So I'm going to connect from there to there, and for now that's going to have to do it. And then I'm going to get rid of the lines that I don't want. Just delete that one. Okay, so it seems like I lost my dimension there. It doesn't really matter. So I want to now mirror those parts across. And I need to delete this line and then just extend that one. So now you see, okay, we've got 10 minutes left. So the moment I extended it across, it said, okay, we've got a closed shape. Great, we're in position to have a proper part. So I just want to put in a little bit of put in a radius here, or let's make it 0.5. Just in there. That dimension back. And I'm not sure why this is not. Might be a height thing. Let's just see. I'll put that in. Pretty sure this is going to say I'm over defining. Yes, over defining, because that line there is already connected on this side. Here it's already connected to that piece there. So it's just a matter of this little piece here. Okay, instead of getting it right, I'm going to leave it for now, just so we don't waste time. But I would go back and then fully define the sketch, so it didn't give me that problem. But for now it's good enough. If I exit this, okay, it's giving me an error. Let's see what the error is. Failed to create the edge flange. Try by increasing the gap distance. Right, so there's an overlap here. So a quick update on why this feature, when I showed it to you, A, wouldn't become a fully defined sketch, and B, gave me such problems. So I'm going to exit this. This is what we had, was a radius. Exit the sketch, just to remind you. So hop out. Remember that went around there. So the problem is, anytime that you have a bend of some sort, the sketch itself has to account for the length of the bend, right? So the sketch doesn't account for the length of the bend, doesn't go beyond it. Let me draw it properly, and then you'll see what I'm talking about. So let's go back into this. If I did something either like a circle in which I put in a circle something like that. So that's one solution, not a problem to do that, both as far as what's practical and what Solidworks will accept. So I'm just going to quickly define this a little bit. Let's make that like that. Give this an offset of 0.05. That's okay, and then just trim that. So you'll see that the sketch has gone grey, which means it's good to go, but it won't fully define. Let's hop over to the other side and try something a little bit different on this side. So this is what you would more typically do, is you would offset, sorry, let's go to that, offset by say 0.3 of a millimeter, just this line. And then we're going to get rid of the fillet, and then just extend these two lines upwards and put a tangent arc on there from that point to that point, and then just fully define it quickly. So delete that, there we go, grey means the sketch is happy. Let's make that 0.1 or something, it needs to be tiny. Okay, I think, why will it not, right, so this piece here needs to be made vertical. There we go, it's gone completely black. So we've got two different versions on this. Let's see what happens when we exit. You see now it actually gives us a bend, and that's because I've permitted the bend to continue up past the point at which the bend would take place. Otherwise, Solidworks interprets that as not a legitimate cut if this cut is at the level of the extremes of that bend or below it. So on that end, and this end will also work, maybe not in the same way, but will still give us the result, some sort of result. Okay, so it's almost the same, it's pretty good. So either of those two solutions would work. But we can just test by flattening. No, flatten. So if I really wanted to solve it, I could go in here and put in a sketch and actually cut that piece out, and that would solve it. So let's just, while we're having a look at this, while it's flattened, we've got a few more minutes left, I'm going to show you how to put in something which cuts across a bend. So I'm going to first unfold, and when you push the unfold command, it's going to ask you which face do you want to keep fixed, and that's obviously this primary face. And you can say which ones you want to unbend, but easier just to say collect all bends, and then when you unfold it, it'll unfold the whole thing. So I can now go and put in a sketch. So I'm going to put in a sketch onto this face, lock it in place. Straight slot. I'm going to put the slot in across all three. It's dimensioned it for me. Make that 2 millimeters. 19, 9. That's okay, good enough. And then let's just quickly give this a position. All right, and then I will see if we can get this right to do a quick linear sketch pattern. So you use the linear sketch pattern to put a series of these in. Let's make it something like that. Just reduce the spacing by 6 or so. Go in the opposite direction, just like that. And we'll leave it for now. And so I can exit the sketch, and without folding or doing anything, use that sketch to punch a hole in the sheet metal. So I can link to thickness. You see I've done cut extrude, link to thickness. Okay, and so now when it's in this unfolded position, you see it says unfold. So have a look in the feature manager. This tells you a story. Unfold, and then I didn't cut extrude, and now I'm going to fold again. So under unfold is fold. It's already selected the face which I selected to unfold. I can simply say collect all bends. It'll collect them. When I click OK, it'll push everything together, and I have the slots going across that bend. So that's how you cut slots across a bend. I could have made those extend, of course, and that's the basics of it. Right. We don't have much more time. Are there any other questions? I'm just having a look at someone's giving me a message here. Seth.
Fold?
Yeah.
Would we need to put those cuts into the design now already?
Yes, I'm going to ask you to put cooling vents into the design. Yeah.
All right.
Okay. All right. So, but it's not too difficult, is it? I hope. Just as long as you follow the sequence, unfold, then do your cut, then fold again. So whatever you do, don't use the flatten one as the basis to put a cut in. It won't work. So the flatten is just a visualization tool. It doesn't do anything else. Okay, and then the sheet metal is the same functionality as everything else. You can add corners in, or chamfers, fillets. Give that a fillet of 1. So I do a lot of sheet metal. I like to fillet all the corners that I can, just so that people who are on the production line don't go cutting themselves. So I try and find all the corners and give them some sort of radius. Also helps in laser cutting, because it's easier for a laser cutter to go around a corner than it is to meet a sharp edge. So it actually speeds up the laser cutting slightly. All right, just to see how much more time we've got, can we start the last bit? We don't need to. I think that's probably enough for today. The rest we'll deal with next week, and then I will obviously put the project together in the meantime, and then give that to you. But we've gone through a lot today, I think. It's a lot to absorb and learn. So unless you guys are suckers for punishment, we'll finish it here. Is that okay?
Sounds good. Thank you, Phil.
No objections. And you've got deadlines tomorrow, so you want time, eh? Okay, everybody. Thank you for watching. I'll see you next week. Yes, just a last thing. If you need help, some people have asked me for help. Please, if you need help, send me files, send me pictures, show me where you've got to and you've gotten stuck. Then I can help you. But if you just say, what am I missing, or what do I need to do, and you don't give me enough info to go on, in other words, specific detail, then I can't help you. I need you to give me the details of where you're at, and I'm very, very willing to help you, as I've told you before. All right, good luck, guys. We'll see you next week. Cheers.